replica sets that you don't have to take downtime in order to do maintenance. You can take backups, you can do index rebuilds, you can even request entire hard disks while the entire replica set as a whole is still on. From your developer's perspective, it's a nice feature. Replica sets are transparent to the application. You basically have to change only a single line of code in order to use replica sets. And with a caveat, you can use replica sets to do a limited amount of rescaling. We'll talk about that as well. So at this point, I want to move on to the basics of replication. In MongoDB, what a replica set is a cluster of some number of servers, typically 3. And one of those is the primary. And the primary is special because when you write to the replica set, you write to the primary node. By default, the reads go to the secondary node. However, by default, the reads go to the primary node. And that way you get a lot of useful benefits, including you get your own rights guaranteed. Optionally, if you like, you can send your reads to the secondary node. Okay. That primary is picked automatically by the replica set by a consensus election. We'll be talking a lot about that. And there is automatic failover. So if that primary node fails, another node can take it over. And there's automatic recovery so that if a node goes down and then comes back up again, it automatically synchronizes with the rest of the set. So we'll be talking about that for the rest of the webinar. The way that replication works is you have these 3 nodes, and you can have a 1-node replica set, which isn't much good for anything. You can, in theory, have a 2-node replica set, but it really only becomes interesting with 3 nodes. And the election establishes that one of those nodes is the primary. So what happens is the data replicates from the primary node to the secondary nodes. Well, what kind of outages could you have, just in general, for any database? Well, you could have a planned outage where you're doing a hardware upgrade, or you're changing the operating system, or you're upgrading the software. Or you could have an unplanned outage where your hardware fails, or there's a region outage, or there's a data center outage. The good news about replica set is that they let you do maintenance without downtime, and they provide automatic failover in the case of an unplanned failure. And we'll be talking about those just a bit. We'll start by talking about automatic failover. So for automatic failover, again, you have the 3 nodes. You have the primary node, and in this case, 2 secondary nodes. And the data replicates from the primaries to the secondaries. There's an election that establishes that primary, and the data replicates out to the secondary nodes. But what happens if the primary fails? Right? At this point, replication stops, and that node is down. This is where automatic failover kicks in. What happens in this circumstance is that there is an automatic election of a new primary if there is a majority. And we'll talk about that majority a lot in just a bit. So again, the 2 remaining nodes in the replica set will negotiate which one is the new primary. A new primary will be elected, and the remaining secondary will replicate from it, and the replica set will continue to function in its normal manner. When this node, that failed node, finally reboots, it will automatically recover itself. It will reconnect to a member of the replica set, probably a secondary, and it will synchronize up with all the operations that it missed. It will then attach itself again to the primary, fully caught up, and a full-fledged member of the replica. And at this point, the replica set is up and running. You have one primary node, you have two secondary nodes, and it just so happens that the physical machine, the physical node, which is the primary, is different than it was before, but the replica set is still in its full functioning capacity. So now what I want to do is I want to take a little bit closer look at how failover works and how these elections work. And this is important so that you can have a replica set that will stay up in the event of the failure of one or more nodes.
On Thursday morning.
So let's talk about how primary election works. In this example, we've got a replica set that's made up of 3 nodes. There's one primary and 2 secondaries. And the important rule here is that you must have a strict majority to be elected primary. So in this particular case, there are 3 nodes in the replica set, and that means that 2 votes are required in order for that primary to be elected as primary and to serve in that role. Replica sets are designed not only to survive the failure of individual nodes, they're also designed to survive network outages, network partitions. And so this is the result. As a result of this, we have this rule, which is that the partition can see a majority of the cluster and it will elect a primary. What do I mean by that? Bear with me and I'll show you in just a few moments here. So let's take a look at this replica set. Again, 1 primary and 2 secondaries. And let's say that one of those nodes fails. So you look at this and see, okay, 2/3 of the cluster is available, right? Out of the 3 nodes, 2 are up and available. So that means that there is a majority. It's a 2 out of 3 majority. That is a strict majority. And the primary continues to serve as a primary. Now, how do they know this? Well, the nodes in a replica set are continually checking on each other. Every node is contacting every node in a replica set is continually contacting all the other nodes in the replica set every 2 seconds and checking to make sure that it's up and to see that it's okay. If that node fails that check, if the primary goes to that failed secondary and tries 3 times and can't contact it, it says, okay, that node is down, and it adjusts its picture of the replica set accordingly. Let's take a look at another example. Again, we'll start with a 3-node replica set, 1 primary, 2 secondaries. Let's say both of the secondaries fail for some reason. At this point, the primary sees, oh, there's only 1/3 of the cluster available. I only have 1 vote and I need 2 in order to be a primary. And at that point, the primary will step down and it will change itself to a secondary. As a secondary node, it can satisfy reads. Applications can connect to it and read data, but they cannot write to it. They will not be allowed to write to it. And it will continue in this read-only mode until it can see a majority of the votes. Now, you might ask, why is this? Why don't you want this to continue? And the reason is to make sure that the replica set does the right thing in the event of a network failure. So I'm going to talk about that next. So again, let's assume that we have a replica set. It's made out of 3 nodes, 1 primary, 2 secondary. Now let's say that there is a network partition. So that means that there's a network failure, and that secondary node that's below the yellow bar cannot communicate with 2 nodes above it, and vice versa. So what is this? From the perspective of the 2 nodes above, that secondary node below the yellow bar has failed. When they try to contact it, ping it, ask it for its status, it says, not there. So from the perspective of those 2 nodes, it's a failed node. Now, this section of the partition, this side of the partition, there are 2 out of the 3 votes available. So 2 out of 3, that's a strict majority. So this primary continues to be a primary, right? On the other hand, on the other side of the partition, this, look, it can't contact the primary or the other secondary. It says, okay, those 2 have gone away. Only a third of the votes is visible. I have 1 vote out of 3. Therefore, I'm not going to step up as primary. This is really important because what it does is it prevents the split brain problem. In order for a node to be elected primary, it must see a strict majority. The primary node is the only one that can accept rights. So there's very careful engineering done to make sure that no matter what happens, however many nodes go down, what happens in a network partition, there's only 1 primary at a time. And this prevents the split brain problem. You imagine for a moment that that secondary node down below the partition could step up and become a primary, and you would have 2 primary nodes. They would both accept rights, and you'd have conflicting rights and no automated way to resolve them. So the election code is very carefully designed to make sure there's only 1 node primary at any given time. And the way that it does that is making sure that the node has a strict majority of the replica set. Now this can lead to problems. And in particular, it can lead to problems if you have a number of nodes in the replica set. So let's take a look at this. Let's say you have in the replica set, it's an even number, and there's a network partition. Well, what happens? So the top 2 nodes can't see the bottom 2 nodes, and the bottom 2 nodes can't see the top 2 nodes. So at this point, the top 2 nodes look and they say, oh, we can only see 2 votes out of the 4. 2 votes out of 4 is not a strict majority. It's only 50%. So this primary will step down, and you'll have 2 secondary nodes at the top. They'll both be able to do reads, but you cannot write. You can no longer write to the replica set. Similarly, only half of the cluster is visible. These 2 will stay in read-only mode. So what this means is even-sized clusters with an even number of nodes in them, are really not a good idea. An odd number of nodes, which means an odd number of votes, is really good when you're talking about a MongoDB replica set. Let me take a momentary digression. In a replica set, there's really 2 types of nodes. There's the regular nodes, or the data-bearing nodes, and they actually have a copy of the data. And there are these arbiter nodes. Arbiter nodes hold no data, but they can vote. And they're used to break ties. So you work around this problem we just described. Another way to think about it is you have the secondary primary node. Well, the secondary node is just a data node. It's secondary nodes can be set up with different priorities. We'll talk about this in a moment. We'll talk about the other configuration options that you can have. Actually, we'll just briefly touch on those. Those are for a more primary node, and this is critical. Just a data node that won the election. So you have your secondary nodes and your primary nodes. They are both data-bearing nodes. The primary node is the one that won the election. Arbiters have no data, but they have votes. So go back to this situation where you want to have only 4 data-bearing nodes. You solve this problem by adding an arbiter. Now that you add an arbiter, there are 5 votes. Okay, so you can lose 2 votes out of the 5 and still have a strict majority, and your replica set will stay up, and you'll still have a primary and be able to make rights. So now we've talked about this, let's talk about various ways that replica sets allow you to have high availability. As we said, with this failover capability, somebody pulls the plug on a node, or if there's a network partition, whatever, the automatic failover will kick in. Now, the other thing we talked about is doing maintenance without taking downtime. Let's look at what that looks like. So again, let's say you've got a replica set, 3 nodes, 1 primary, 2 secondary, and you want to do maintenance on all 3 nodes. Well, you start by taking one of the secondaries out of the set. What does that mean? Well, if you want to do operating system maintenance, you just stop that MongoDB node, and it will look as though that node has failed, and the remainder of the set will continue normally. If you want to do some MongoDB, you want to build an index, if you want to do a compaction, you would then start up that node, but without the replica set flag and listing on a different port. That way, the remainder of the replica set cannot contact it, and this node thinks that it's a standalone, and you can go ahead and do the maintenance that you want. So once you've done that, you've got your maintenance going on, okay? When you're done, place the secondary in the set. If it's running, you stop it, and with the replica set flag on the port that the rest of the replica set expects, and you wait for it to catch up. So now you've done the maintenance on 1 out of the 3 nodes. You then go ahead and do the same thing for the next secondary. Take it out of the set, perform the maintenance, and replace the secondary in the set. I'll wait for it to catch up. So now the only thing that you've got left is to work on the primary node. So what you do at this point is you step down the primary. Okay? You tell it, want you to convert it to a secondary. That will trigger an election, and some other node will become primary. At this point, the former primary node, now the secondary node, you can maintain it just the way we did the others. Take it out of the set, perform the maintenance, have it go back. And now you've done this maintenance, your replica set has been up the entire time, and you have not had, and you've been able to do maintenance on the entire, all 3 nodes in the replica set without having to take the replica set offline ever. Now that you understand this, I want to go back to a question. Sometimes people say, well, what is the minimum number of nodes that you need in a replica set? And technically, the minimum number of nodes that you need is 1 primary, 1 secondary, and 1 arbiter. The question is this a good configuration? So let's see what happens when you try to do this scheduled maintenance with no downtime. You have your primary, your secondary, and your arbiter. Remember, the arbiter votes, but does not have any data. So what you do, you take the secondary out of the set. All right? So we perform the maintenance, so it's isolated from the rest of the set. Meanwhile, the primary there is taking writes. So the data in the primary node is now different from the data in the secondary node. Now let's say the primary node fails. At this point, you've got a problem. There are 2 problems. The first is that the replica set is down, and the second is that the data, the only remaining data that you have on the secondary, is out of date. So this is a problem. My strong recommendation is that if you're going to have high availability data nodes, so if you've got a replica set, you need to have 3 data nodes at a minimum, so that you can do this kind of rolling, no downtime maintenance without being at risk of losing your data. The next topic I want to touch on is how to configure so that you don't have a single point of failure. So this is a rack in a data center. And again, let's look at your replica set, 1 primary nodes, 2 secondary nodes. And in this configuration, we set them all up in the same rack, in the same data center. So what's the problem? Well, what happens if somebody hits the switch on the top of the rack and all three servers get shut off at the same time? What happens if the rack falls over? This is a problem. Okay? All the higher availability built into MongoDB can't help you if all three of your nodes are physically going to fail at the same time. I've actually talked to customers who had all three nodes as three different virtual machines in the same physical host server. So if there's any problem with that host server, all three of the virtual nodes go down. This is not a good idea. So here's something that we can do that's a little bit better. We have these three nodes, and they're in different racks in the same data center. So this way, if one rack fails, the other two are left, and you still have your application up and running. On the other hand, what happens if this data center loses internet access or it burns down? So can we do better? Absolutely. We can start with having two different data centers. Again, we've got three nodes in a replica set, and let's just say we put two of them in San Francisco and in Dallas. So this is good, but the thing is, remember, in an election, any node could become primary. So let's say you don't want the node in Dallas to ever become primary. Well, you can arrange for this by setting priorities on the individual nodes in the replica set. And in particular, setting priority 0 says that this node will never become primary automatically. So what this means is that if you step down one of the priority nodes in San Francisco, you are guaranteed that the other priority 1 node will step up and become primary. Your primaries will always be in San Francisco. So this is good, but what happens if the data center in San Francisco crashes? Well, then you have one data node. It's in Dallas. It has all of your data, but it doesn't have enough votes to become primary, so your application is not available. We can do better. So let's have 3 data centers. And just to show you how this might work, let's have 5 data-bearing nodes. 2 of them are in San Francisco. 2 of them one of them is in Dallas. In this configuration, any one of your data centers can crash, and your application will stay up and running. The San Francisco data center goes down, you lose 2 nodes, but you still have 3 out of 5. That's the majority. They'll continue to run. Now, let's say that, similar to the previous slide, you really would like to have your primary be in the San Francisco data center, if at all possible. You can do this by setting priorities. So not only can you set the priority 0 on the Dallas data center, which says that node will never become primary, but you can also set relative priorities on the remaining nodes. So the relative priorities are just that, they're relative. And what that means is when an election happens, the most up-to-date node with the highest priority is going to be elected primary. In this case, we've set priority 10 to San Francisco and priority 5 to nodes in New York. This means if there's an election and any of the nodes in San Francisco are still up and available, then one of those nodes will be elected primary. Only if neither one of those nodes is available will a node in New York be elected primary. Notice these are relative. So if you set the priority on the New York nodes to be 5 and
Thursday morning, 11:30.
then if a node in New York was up, then a node in New York will always be elected. So these are relative. They're the absolute priority. Only one that is significant is priority 0, and that says it will never be a primary. We'll still vote. Notice, as a side note, if you have multiple nodes that could be primary, you should really size them equally. They should have the same amount of RAM, same amount of disk space, same number of CPUs, same amount of I/O capacity, because any one of them could be primary, and you want it to be big enough in order to handle the load. You can get yourself in trouble if one of your quote-unquote secondary nodes is undersized, and then it becomes primary, and then it cannot handle the workload. So I want to recap what we've covered so far before going on to the advanced topics. So again, a replica set contains some number of nodes. One node would be the primary. All writes go to the primary, and the secondaries maintain up-to-date copies of that data by continually copying from the primary. If the primary fails, then the replica set can elect a new primary. A strict majority is required for that election. And then what happens is when the former primary recovers, that as a secondary and copies in all the data that's been inserted or updated in the current primary since that node failed. A network partition is something that will prevent the nodes from communicating. A replica set treats all the nodes on the far side of the partition as down nodes. As we said, a node must get a strict majority of the votes to be elected primary.
Can you hear me?
So that you do want to have a number of votes in your replica set to have maximum.
Hey, how are you?
And if you want to have an even number of data-bearing nodes, you can put in an arbiter in order to break the ties.
So just call.
Finally, it's important to spread your nodes across multiple data centers in order to have maximum availability. So, having talked about this as cassettes, I have two more advanced topics I want to get to. One is talking about how your applications will use the replica set. So, the applications view of MongoDB, the application code that you write is going to go through one of the MongoDB drivers in order to connect to your MongoDB instance. If you're connecting to a single node, again, you'll go through the MongoDB driver and you'll specify the host name and the port of that single MongoDB node, and the driver will make a single node connection. And your application does its queries and its inserts and its updates. On the other hand, you can configure your driver or your application to connect to a replica set. So your application code still connects to the driver, and the driver has code in it where it detects where is the primary in this replica set and connects directly to that primary. So the way that this works is that when you make the connection, you literally change one line of code, and instead of connecting to a host and port, you make what's called a replica set connection. So you connect to the set name, in this example it's my set, and then there's a slash, and following that is a list of all the hosts in the replica set along with the port numbers that that replica set is listening on. So in this example, I've got 3 hosts. They're called hosts 1, 2, and 3. They're all listening on port 27017. By the way, you do not need to list all of the hosts in the replica set because the driver will treat this as a seed list. It will contact each host in turn, and then from that host, it will get the list of the full list of all the members in the replica set. However, as a best practice, it's a good idea to have all the hosts because in case one of them is down, the driver will still be able to contact the replica set and make that connection. Now, I said I would talk about reading from the secondary. This is where you would do it. So in your application, by default, all the reads go to the primary node. You can, if you wish, request read from a secondary. How you do that depends on the driver, but there's some flag that you will put in either on the particular query or on a particular connection which says a secondary is okay, and the driver will pick a secondary and direct a read to that. The question is this a good idea? And generally, or often, the answer is no. Because MongoDB makes no guarantee about how up-to-date that secondary node is. So that secondary node can be what we call lagging. In a healthy replica set, that node will be up-to-date within a second or so of the primary. But if you have a networking problem, or if the host has a performance problem, or if any one of the half dozen other problems occurs, that node may lag. That node may lag by seconds. It may lag by minutes. I did see lags in the multiple hours. And what that means is the data on the secondary node is potentially stale. It's potentially out of date. It may have been updated on the primary and not yet made it to that secondary. So this is why secondary reads are a tricky thing. If you want to do that, you have to know in your application that reading stale data is okay. Now this may be okay if you're doing something like blog software and the read misses somebody's blog posting for 5 minutes. That's probably not a problem. On the other hand, if you're using credit card data and you want to check if something is up to date, stale reads are probably a problem. So you're going to have to check that out for yourself. The other thing I want to talk about is how failover works from the application perspective. So again, we talk a lot about how failover works in a replica set. Let's see what the application sees. Then your application is connected to the driver, and from the driver it's connected to the replica set. Let's say that there is a failure of that node, and that node crashes. Well, the replica set now has no primary, and that primary has gone away. The driver will detect this. The driver will detect that the primary has failed, and it will send an exception back to the application code. This is a connection exception. Exactly what exception it's going to send back is going to depend on which driver you're using and what language you're using. But one key thing about writing an application that's going to be using a replica set is that it has to be prepared for failover. And in particular, it has to be prepared to receive that connection exception. So after that exception occurs, there's going to be an election. And a new node will be elected as primary, and the MongoDB driver will detect that and will connect to it, and your application can proceed. However, an important thing to note is this election takes time. It takes about 15 to 30 seconds, which is a lot of time in computer time. So your application code must not only be prepared to receive that connection exception, it must be prepared to wait for 30, maybe 45 seconds for a new primary to be elected if that occurs. Again, once the former primary steps up, it's still in the secondary, but the driver continues to connect to the existing primary. Finally, last thing, I want to talk about durability and replica sets. So durability is the property that once you send a write to a database system, it's there. And even if the database crashes, that write is still there and you can still read back what you wrote. So the way I want to talk about it, first I want to talk about durability in the context of the node system. So again, this diagram should look familiar. You've got the application code, it connects to the driver connects to the single node MongoDB. And this is what happens when you send a write operation, like an insert, an update, or a delete to MongoDB. So the driver sends the information, that write information, over the network to your MongoDB node. Your MongoDB node is going to validate that write operation. So what do I mean by validate? Well, it's going to check to make sure that you have permissions to modify the collection. It's going to, if you are doing an update, it's going to check to make sure that your update is legal. You're not, for example, trying to increment a string value. If you are inserting something, it's going to check to make sure that you're not going to violate any unique constraints. Once all that validation is done, MongoDB then writes those changes to the in-memory copy of that document. So that's the data in RAM. So it's made the changes, and any subsequent read will see those changes. But this is not yet durable, because if the node crashes at this point, then that data in RAM hasn't necessarily made it out to disk. After it's been sent to RAM, the MongoDB will then go update the journal file. Now, the journal file is just a record of all the updates that have happened. And every 10th of a second, every 100 milliseconds by default, MongoDB flushes that data out to the journal file. Once it's hit the journal file, it's durable. If that node crashes, when it comes back up, the journal file recreated. One of the things you may have noticed here, so the first point is that this is fully durable. This is durable just like any other database system. The other point is that you may have noticed there's no validation going back to the application. So when the write goes out, it gets validated. If it's validated, updates RAM, and then the journal file is updated, and the application receives no notification. This is so-called fire and forget writes. This is appropriate if you don't particularly care if the write succeeded or not. However, you may care if the write succeeded. And if you do, if you want your application to know if the write succeeded or not, then you have to use something called get last error write concern. And here's the way that works. So as before, the driver sends out the network, and then it immediately follows that with a get last error command. So sometime later, MongoDB will get the data, it will validate the data, and it will send back a response to the get last error result saying whether or not that data was valid, whether or not that write succeeded. And that is how the application knows if a write succeeded or not. Most relational database systems don't let you control the durability level. There's just commit, and then you get something back from the commit, and you know that it's fully committed. MongoDB actually allows you to control how much durability you care about. And you do that by setting the write concern. For a single node, there's 3 levels of write concern that you set. So there's network acknowledgement, checking, and then there's journal sync. So what network acknowledgement does is the I got the site without ever having validated. You know that actually don't validate. The second one is called that's check. So what happens then is check to make sure those validity checks pass. Then it will send back and say, yes, it's okay. And if any of those validity checks fail, it will send back an error condition. The last one is journal sync. And journal sync says if there is wait, so send the write, validate it, wait what makes it through to the journal, and then and only then send back the get last error result. So if for whatever reason that write gets sent but it never makes it to the journal, then the driver will know, and thus the application will know that write. So let's see what that means in the context of a replica set. What does it mean for a durable to have 5 nodes? And what I will say is that a write that is replicated to the majority of the nodes.
Yeah, he just says he travels a lot.
So why is this? Well, if that write makes it to the primary and 2 other nodes, so we have 3 out of 5, then when, let's say that primary crashes, but it hasn't made it to the journal. But whatever node is going to be elected is going to be the most up-to-date node, and it will become the primary. So that way, you know that if this write has replicated to majority of the nodes, it's going to be durable, because that write will be present on the node that becomes primary. So once that something is written to the majority of the nodes, then it's durable. Notice that there is no guarantee of which nodes will have received that write. There is a feature in MongoDB which lets you control that. It's called tag sets, but it's beyond the scope of this presentation. So now, knowing that, we can go back and talk about a network write concern. So if this is a network write to a replica set, followed immediately by a get last error command, we can say, wait until this write has replicated to a specific number of nodes. You can say, wait for a specific number of nodes. So W:2 says wait for 2 nodes, that's the primary and 1 other node. That's the majority, that write is durable. There's a shortcut that says W:, and then uses the string majority, and that says whatever the majority of data nodes is in this replica set, so it's replicated to that. So if it's 5 nodes, then it waits for 3. If it's 4 data nodes, then it also waits for 3. If it's 3 data nodes, then it waits for 2. So you can put that in your application and have it do the right thing automatically. Now, one of the things you'll notice is that you can also say this for a tag set. Again, tag set is beyond that, but if you want to specify a tag set that specifies specific nodes, you can do that with a network write concern as well. The other thing is that this write might time out. You may send it to the primary, and for whatever reason, it can't get to both a majority, or it can't get to secondary. Well, it'll wait forever for doing that. If you set a timeout, then when the timeout expires, you will get an error back in your application, and you can handle it appropriately. So, we've talked about a lot today. I want to somewhat wrap it up, and then after that, I will take questions. So if you have questions, you can start typing them in now. So again, the point of replication is to keep your data safe and available. You want to have multiple copies so that if something happens to one copy, you have other copies available. And because there are multiple copies and because there's this automatic election process, even if a node goes down, another node will be elected primary, and the data will continue to be available, and your application will continue to be available. So what are the features? Right? We talked about this. There's this high availability, and this automatic failover with the election. Because you have multiple data in multiple places, you can do disaster recovery. If worse comes to worse, you've got it in that extra data center, in the elected primary. You can use that data to restart your application. Because you have multiple nodes and because of this automatic election, you don't have to take you don't have to take downtime when you're doing maintenance. And the replica set is transparent to the application. Again, you have to change one line of code, and then we'll connect to the replica set and automatically reconnect to the primary. And if you have the appropriate write concern, your writes are going to be durable and they're going to be network durable. So if you want to move forward with this, I just say go ahead and use it. This is really easy to set up. We've been talking about this in terms of a production environment where you want to have nodes on different machines and different data centers. But if you want to test it, you can have multiple ones on a single machine. just run multiple instances of MongoDB on different ports, and then you can play with that. You can have the failover and the replication tested for yourself. We do have a bunch of online documentation. If you want to get started, I do recommend the tutorial at the location listed on your screen. And there's a whole bunch of other documentation online for the advanced features. So with that, let's go ahead and look at some of the questions. So I have a question. So let me just take a look at these questions. So the first question is, what parameters are considered when electing the primary? So for a primary to be elected, it has to get a limitation of the votes. If you are not using priorities, if ever node happens to nominate itself for election first, if you are using priorities, it's the highest priority and most up-to-date nodes
So you'd be open to
that are considered. One, which of the secondaries has the newest copy, and the other one is priority, and it's newest copy first, and then among the ones with the newest copy, one with the highest priority. Do we have to wait until the update is journaled on a majority of nodes, or is W:? Unfortunately, right now, there is a way to wait until the update is journaled on a majority of nodes. However, in practice, in the real world, W:majority is enough because the odds that they'll all fail at that same time are vanishingly small. So there's a question, can I have one machine with two databases, and which database has the replica set? So I'm not quite sure what you mean to this, by this question. If you mean, can you have one machine with two nodes on it, then you can do that for development and test, but it's not advisable to do that for production. Each node should be on its own machine in a production environment. If you mean two databases within a node, replication is done on a per node level. So if you have a node, which is an instance of MongoDB, and it has 10 or 20 or 100 databases in it, then all of the databases in that node will be replicated to all the other nodes in the replica set. So those will all be exact copies together. And then there's a question about migration from MySQL to MongoDB. And do you have to consider replica sets? And yes, you have to consider replica sets because they are handled differently than MySQL. But your entire application is different than MySQL. The data model is different, the query model is different, the query language is different. You cannot take a MySQL application and convert it over to MongoDB. There's a large difference in the way that the data is stored, the way that it's formatted, the way that you query it. So you're going to have to rewrite everything anyway. And replication is the least of your worries. As I said, you write it for a single node application, and then you just go ahead and make a replica set connection, and you're pretty much done. So are there any other questions? If not, we'll call it a day. Thanks very much for showing up, and you all have a great day.